Welcome to Are You Chemistry GCSE Ready? This playlist takes you through loads of example questions and guided solutions for every single topic in your chemistry GCSE. So it's a perfect way for you to test your chemistry knowledge. If you feel like you need a quick review or you just want the ideal revision companion for these videos, then make sure to download my free chemistry GCSE revision notes. I've linked them in the description below. Or if you're ready, let's dive straight in.
Okay, questions about metal reactivity. So how can we work out the relative reactivity of metals by observations, by looking at their reactions? And basically, the more vigorous the reaction, well, the more reactive the metal. So the rate at which the bubbles are produced is something that you might look at, or the largest change in temperature for these reactions is something you could look at. Also, you could ask yourself the question, does a displacement reaction occur because only a more reactive element is able to displace a less reactive one? What is the reactivity series and how is it best to understand it? So basically, it's a series that ranks the reactivity of different metals, but hydrogen and carbon appear on the series as well. And the higher up you are, the more reactive. The higher up, what does that mean? It means the more easily atoms of this element are becoming ions, okay? Whereas lower down, the more easily ions of that element are becoming atoms. So you can think about it like that as well. So let's do an example. Will iron 3 oxide react with aluminium? What will the balanced equation look like? So first questions first, basically what we're asking ourselves is aluminium more reactive or not than iron? Because if it is more reactive, then I can have this displacement reaction take place. How do I figure that out? I go to my reactivity series. Remember, you actually need to learn this off by heart. So think of your own mnemonic maybe to help you. But luckily for me, I've got a list here. And yes, aluminium is higher on the reactivity series than iron, which means that it is capable of displacing iron. Okay, next thing I need to think about is my formula for iron 3 oxide. So that's 3, those Roman numerals are telling me that my iron ions have a charge of +3, and then my oxide ions, oxygen is in group 6, so it has a negative charge of 2. And remember, I need to balance those charges, so add another oxygen with 2 more negative charges, 3 charges for my iron +3, -4 for my oxygen, still not balanced. Add another iron, so now +6 on my left-hand side positive charge, but -4 on my right-hand side negative charge, still not balanced. Add 1 more oxygen, and now I've got +6 and -6. Perfect. So then my aluminium oxide, which is what I'm going to end up with here, I have got, sorry, that +3 and -3 should be +6 and -6. Then for my aluminium oxide, I have got my aluminium here, which is in group 3, so it's going to have a +3 positive charge, and my oxygen, we know already that the ions have a -2 charge, and again, add another oxygen, no charges still aren't balanced, +3 -4, another aluminium, +6 -4, still not balanced, another oxygen, fine, and those charges are balanced with a +6 and a -6 on that side. Okay, I've got the 3's wrong again. Anyway, so iron oxide 3, therefore I needed 2 of my iron ions and 3 of my oxide ions. So iron Fe2O3 plus my aluminium gives me, and I had 2 of the aluminium, Al2O3 plus iron. And now what I need to do here is I need to make sure that everything here is balanced. And if I look at my left-hand side, there is two iron on my left-hand side. On my right-hand side, there's only 1 iron, so that's why I've added the 2 in front of the iron on the right-hand side. And am I balanced? Not quite, because my aluminium on my left-hand side, there is just one, and there's two on the right-hand side, so put a 2 in front of that aluminium on the left-hand side, and then we are all balanced. That's my final balanced equation.
Just before we go into the tips and tricks section, if you do want some extra advice to getting that grade 9 for your GCSE, then why not download my free 20-minute exam success guide? Just click on the link in the description below. I'm going to give away all of my best advice and secrets, and completely for free, so why not?
Just remember as well with these reactivity series, it's not just your displacement reactions like the one we did on the previous slide that you need to worry about. You could think about which of your metals will react with cold water, which will react with steam. You need to remember those, and you need to appreciate that when one of those metals that will react with water reacts with water, you produce the metal hydroxide and hydrogen gas. So that can help you to figure out what the equation should be for those as well. So you need to learn your reactivity series. I would get it done as soon as possible because it makes everything easier in the long run. If you're struggling to generate the formula for those compounds, like if you found it hard to do the iron 3 oxide there or the aluminium oxide, go back to your ionic bonding and practice your ionic formula. You now have two definitions of oxidation and reduction. They are both true, so you can read the question carefully to know which one is more appropriate. Of the two that we're talking about is the idea that oxidation is the addition of oxygen in a reaction, or you could talk about oxidation is the loss of electrons, and reduction is the removal of oxygen, or reduction is gain, it's a gain of electrons, so either one of those.